Hello, Magneto Hydro Dynamic Propulsion, or MHD effects. Now, this is a pure experiment. It's nothing I've ever tried before. It's one of the things I've been meaning to try, and as my current videos, the topic's been to do with motors and electromagnetic effects. This is a little oddball thing which fits in with that. If you ever watched the Hunt for Red October movie, the submarine Red October supposedly had an MHD drive, which they nicknamed the Caterpillar, but they did also say clear it was a Magneto Hydro Dynamic drive, when I can say the word. And what that is a motor that uses a fluid as the moving part. So this frame has got a stack of, it's just a piece of cable trunking, by the way, the black part, and it's got a stack of little neodymium magnets stuck to it, just with their own strength, all the same polarity, so they're all attracting through the thickness, and all the same, all north one side, all south the other side, which I can demonstrate this little magnetic indicator when it doesn't stick. I don't know if you can see that. Let me get a bit closer. It's red on one end. The lighting's you can just about see the near end to the frame at the moment is the red end. If I put it down the middle and then stop it touching, which is not easy, it's stupidly strong. You see the red end is still towards me, no matter anywhere I put it in there. And if I put it this side, the red end is still towards me. So it's all the same polarity all the way through. So it's a consistent, and hopefully in the middle at least, a fairly parallel field. And I've got two pieces of thin copper strip, which I've just quickly scrubbed up a bit on one surface with some Scotch-Brite nylon scourer, which is a dishwashing pad, which are going to be the electrodes. So one of those will go underneath and one on top. And the working fluid is water. Now it needs something in it to make it conduct. This is just tap water, and I've got another bottle down here to top it up. And I've pulled up some and cut up some little bits of just foam rubber to float in it to show movement, so you can see if anything moves, which I may or may not yet. Now I'm just going to chuck some salt in it and give it a shake round to make it conductive, or more conductive. Don't know how much, just chuck some in. So I've got another bottle here, it's just tap water. So I'm going to pour that in, which will help mix it. Hopefully not splash too much, splash over the electronic behind here. And then I need enough in this oven dish to completely cover the plastic frame, so I can sit the other copper strip on top. You notice on there I've got the end magnets are tied to the plastic because they kept trying to push themselves off the end. Because they're all the same polarity, they'll repel. They're trying to spread apart all the time. The ones in the middle behave because they're equally repelled from both sides, but those end ones are trying to push out. And also then got a couple more bits of lacing cord just tied around it, which will act as supports for the top copper strip. So pour this in, hope I don't make a mess. See how much more I need. No, not quite as much again, but a bit more. Now if you're going to do this as a serious experiment, you'll be better off using stainless steel plates and possibly a weak alkaline solution as the electrolyte, so you're not producing chlorine. Something like sodium hydroxide, which is a weak solution, is less likely to cause long-term degradation. No, more still. Most of that salt has now dissolved, or it's run into addition, I can't see it. And it's got nearly 3 litres or so, it's taken quite a bit. Don't want to overdo it, but it needs enough to work. It's almost there. Right, I'm just going to pour some straight in that bottle. It's got most of the salt in. Quite surprised about that. Right, that's now completely covered the plastic, but only just. So put that top copper strip in. Let me move these bits out of the way so they're not trapped. If I put this top copper strip in with the, I should wet it first. So that's there with the cleaned up or scuffed upside downwards. Right, okay, I need to hold it. I use the salt pot to hold the wires so I don't keep moving them about. Just stand that on there. That'll stop me just disturbing everything. It's staying, it just wedges in slightly. Right, so if this works, I don't know which way it's going to work, but there should be some level of current, liquid current that is, as in circulation, from one end to the other. I want to start out, well, it would help if I'd strip the ends of the wires rather than leave. I'll see if I can do it with scissors. It doesn't work very well if you can't connect to things. Yeah, that's it. It's crude and whatever, but it works. It's a bit of chewing off with the scissors, and I've got some trip wires. Now I'm initially going to try it at 4 volts or thereabouts with a single lithium cell. Make sure my fingers are dry and see if that has any effect, because I've not a clue what the current's going to be on this. No sparks. I don't even know if there's any current. I should really got a meter, I suppose. No effect. As I said, I don't even know if there's going to be any effect. Right, so let's try it with the 12 volt pack I've got here. It's a 3 series 4 parallel pack. And get the wires to fit the socket. See what that does. It's fizzing, so it should definitely be doing something. But I don't actually see any movement. Let me just zoom in a bit on that. It's definitely got power. But let's try and get some that are not stuck to the side. Oh no, it's just bubbles carrying it about. There should be, theoretically, be some end-to-end flow on that because there's a current in a magnetic field, though the magnetic field isn't particularly strong, no matter how. Oh, I don't know. That looks to be going endways. Yes, there is a definite circulation starting to take place that way. Not very much. I could do something that was neutral density as an indicator, but you can see it's gradually building up circulation. Obviously this size, this scale, low voltage, low current, and not a very strong magnetic field compared to what was supposedly used for propulsion. It's not very active, and also the bubbles are going to be reducing the conductivity because they form an insulating surface on the plates. See, it's full of gas, or hot air, or hot hydrogen and oxygen, possibly. But yeah, you can see the floating bubbles. There's definitely a circulation. Let me try and dropping these in. Sticking my fingers. It's not. Oh, you can. It's not very obvious. I think the light's not very. Let me try a different light. There are now bubbles within the bulk liquid, and there is a definite tendency for them all to be moving that way there, so it must be, and you can see bits of stuff being carried along this way at this side. So yeah, these little bubbles here. So that's it. It is working. It is causing a liquid flow. So it is our weak and weedy a working Magneto Hydro Dynamic propulsion device. Now, it couldn't propel much more than a feather, but it shows the concept. Yeah, I mean the conductivity. Ideally, I suppose, the plate should be vertical, the magnet's horizontal. And to arrange it to work like that. But that would allow the bubbles to clear the plates instead of building from underneath here. Being very careful to try and avoid any endways movement on anything that could influence the flow. So any effects are definitely from the flow this is creating. As you can see, there's a very, very definite anti-clockwise circulation in that dish. Just loosen some of them. All the bits are sticking. I don't know what's an ideal flow indicator for something like this. So surface tension sticks them to the sides when they touch the sides or anything else. But I think it's a good enough indication that it works. Okay, anyway, I'm waffling, it's getting long. So that is now running. It's all the bits you've seen, and that 12-volt battery pack is what's running it. 3 series cells. You have to be careful you don't drop that in the water. Right, okay. The next thing is going to take it all apart and dry all the magnets out. I don't want them all corroding or whatever. I know they're supposed to be chrome plated or something, or nickel plated or something like that, but even then they need washing and drying. And if it's anything like as much fun separating them all, it was getting them all together with them flying all over the desk and keep pinching me. Yeah, it's going to be interesting. Anyway, thanks for watching, and if you like weird technology or projects and general interesting gadgets, then please subscribe and please like the video.